I'm privileged to announce the speaker of today, Mr. A. Gandhimanathan. Mr. A. Gandhimanathan is qualified with M.Tech in Textile Technology from PSG College of Technology, Coimbatore. He is a native of Tirunelveli district, and his only son is working for Aramco in Fujairah. He obtained a diploma in labor laws and industrial relations from Annamalai University and did PG diploma in personal management and industrial relations in NIPM, Calcutta. He started his career in Majora Courts in shop floor production and maintenance. In 1989, he joined with Citra, which is the turning point in his career. During his tenure in Citra, he visited more than 100 mills in India and abroad on consultancy visits. On UNDP projects, he studied in Leeds University in UK and Clemson University, USA, deputed by Citra. From 1997 onwards, he started his corporate management career, starting from Bricard Group of Mills for 10 years, Premier Group for 3 years, and served in GTN Patspin Group in Kerala for 5 years as President Technical. 2016 to 2020, he worked as President in GTN. Between 2012 to 2016, he started his own management consultancy organization by name Vinces SMC for technical consultancy for spinning mills all over India. Now he has restarted the same. He has published more than 35 technical papers in Indian as well as international textile journals, and he has presented many technical papers in textile conferences in India conducted by research associations as well as academic associations. He has been awarded for Best Book by Textile Association of India as a co-author. He is also a recipient of WIPO, World Intellectual Properties Organization Award, for his UNDP Citra project on short staple spinning of jute and its blends. He is always interested in dissemination of knowledge through seminars, conferences to the industry and academic institutions. Currently, he is a management consultant for spinning mills through his outfit, Vinces SMC. We, the Textile Association of India, South India unit, we are happy to inform that we have started student chapter in 3 colleges in Coimbatore, namely PSG College of Technology, Banariamman Institute of Technology, and Kumaraguru College of Technology. Mr. Gandhimanathan is taking active role in coordinating with this student forum, along with our Joint Secretary, Mr. Sivaramakrishnan, and Mr. Gandhimanathan is a managing committee member of our Textile Association India South India unit. And thank you. We are looking forward to your presentations.
Thank you, Mr. Sivkumar. Kandaraj, can I start?
Yes, please proceed. Please proceed.
Yes. Respected President of Textile Association of India, Vice President and Management Committee members, the Managing Directors and the team members from their mills, academic experts and the student members, good evening to all of you. Textile Association of India, South India unit is organizing technical seminars mainly to promote technical knowledge among the manufacturing experts and executives in the industry. I am really thankful to Textile Association of India South India unit chapter for giving me an opportunity to share my experience through this presentation on evolution of maintenance. Let me share the screen also. Screen is visible?
Yes, it is visible.
Yes. At the end of this program, audience should be able to capture the need for maintenance, types of maintenance, what are the 8 pillars of TPM, what is meant by FMEA, what are the 5S methods of shop floor excellence, what are PDM tools, what is SPDM, what is Industry 4 as spoken by many industrial stalwarts, what is SPMF, who are the smart spinners. So why at all we need maintenance? So if there is no maintenance, what will happen? If you don't change the oil and grease, wear and tear of parts will be accelerated. For example, spindle in a ring frame on an average revolves more than 2.88 crores of revolutions per day. Likewise, tin roller shaft revolves 21 lakh revolutions per day. Without timely replacement of oil and grease, how can we expect the spindle or tin roller shaft to perform better or without wear and tear? So continuous running parts result in disturbance also in setting of the parts. For example, in a ring frame auto dopper, there are moving parts for every 2 hours or minimum 1 hour in small coarser counts. So in that condition, synchronization of movements is more important, which is being affected by that. So it needs a resetting of machines. Likewise, this less illuminated areas due to dirt deposits in the sensors and the cameras in contamination clearers will affect the performance of this clearing efficiency of these units. Abnormal heat development due to dirt accumulation, for example, beater shafts in a blow room. Abnormal energy consumption is created due to hot spots in a ring frame motors. Abnormal energy consumption due to non-alignments in a ring frame variators. All this will happen when there is no need, when there is no maintenance. So absence of maintenance will result in deterioration of quality, like rise in imperfection or rise in weak places. And there is a possibility of drop in production if the travelers are not changed in time. There is a possibility of loss in utilization if there is a breakdown. If there is a possibility of higher energy consumption when there is a hot spots in any motor parts. And it will also lead to higher maintenance expenditure. Why we are saying higher maintenance expenditure? For example, if a bearing is not replaced in time, finally the bearing will wear out. Along with the bearing, you will be replacing a shaft, you will be replacing the housing also. That is, the expenses will become threefold instead of a single. So higher maintenance expenditure. Finally, it will also lead to substandard performance. What do you mean by substandard performance? If you take a link corner in any spinning mill, we are expecting the same to be run at 1700 meters per minute for medium and coarse counts. Let us assume we have 10 autocorners of the same age. If the parts are replaced in time as per the maintenance schedule, we expect the autocorners to perform at the same level. But is it happening in all the mills? Invariably, shop floor production cries that 50% of the drums are not in their controllable level of production. Likewise, even in new projects, QAD stops more than 10% of the drums to meet customer expectations. Why it is so? The causes or reasons for this failure can be many, but it is mainly attributed to we are paying less attention to the needs of the machines, especially on replacement or in lubrication or routine cleaning. And we also have less knowledge about the machine's requirements, and we also very, very less trained crew for attention of the same. Finally, it leads to improper maintenance of machinery and its components. Last but not least, which is more important, there is an absence of coordination between the 3 pillars of manufacturing, that is production, maintenance, and quality at the shop floor level. Absence of data, absence of review of performance, absence of adequate knowledge to maintain, non-availability of benchmark levels of, we don't know what is the benchmark levels of performance of an auto corner or a ring frame or a draw frame. See, if we take an auto level draw frame, we expect 0.5 1 meter CV at any point of time. So likewise, we should be able to come, where do we stand? We should know the benchmark levels of performance. And lastly, this absence of coordination with OEM vendors. OEM vendors are there to guide us, help us in times of difficulties, but normally we don't coordinate with the OEM vendors. Now we will look into the evolution of maintenance, which is the topic of this present presentation. Let's start with the first generation maintenance, which is the period of 1940 to 1955. In this period of maintenance, they will allow the machine to run until it fails. The problem will be identified only after leading to the breakdown. Then the components will be changed only after inspection. So we normally call it as a breakdown maintenance, or it is called as a reactive maintenance, because we are reacting to the incident. Examples: twin roller shaft broken in a ring frame, or differential gear failure in a speed frame. OEM vendor will be called for inspection. After inspection, spares will be ordered. Upon receipt of the material, OEM vendor will attend and rectify. So what is the end result? No one knows when the machine will be restarted. So what is the best example for this first generation maintenance, which is happening even today, is ginneries, our ginneries. Double roller gins in Indian ginneries follow this primitive practice even today, which is the root cause for quality inconsistency in our Indian cotton. So what are the disadvantages of a first generation maintenance? Sudden utilization drop of the unit, because no one knows when the breakdown will happen. Surprises to the customers, because when the machine will be restarted, when we can commit to the production, delivery of our production. Stress in shop floor management, because there will be a quarrel between the production people and the marketing people. And there is no fixed time to repair, because we don't know when the OEM vendor will come, when the spares will arrive at our place. And there is no room for forecasting next activity. Nobody knows what is the next activity for this machine, because we don't know when the machine will be restarted at all. But there is a very good advantage for this program. There need not be any budget for regular maintenance. Management is very happy on that. Now coming to the second generation maintenance. This is the period is 1955 to 1975. But it is a planned maintenance system. Here it's a time-based maintenance activities. We plan, we schedule our maintenance activities. But please note, these are all stereotyped activities. Routine machine cleaning, if we fix that ring frame once in 15 days, it will be stereotyped. Once in every 15 days, ring frame will, number one will go for a cleaning. Likewise, we can call it as planned and preventive maintenance. Advantages: it's a planned and preventive approach. We take preventive steps to control the breakdown. And stoppages of machines are well planned and included in our production planning itself. At the beginning of the month itself, the stoppages of ring frames are well planned for maintenance, and production manager is subtracting that portion of the production from the production calculation. And we give less surprises to the customers as delivery schedules are adhered. Parts are replaced in time to prevent breakdowns. But there is a requirement for second generation maintenance. We should have a planning schedule. We should have a schedule of maintenance activities, and we also should control and monitor through our ledgers and records. And we should also review of the maintenance activities and its impact. What do you mean by review of activities? For example, if you do the buffing activity, what should be done? If the buffing is not proper, then it will lead to rise in imperfections. So buffing is an activity should be checked, or it should be reviewed by running the cops in an auto corner clearer and checking for any imperfection, rise imperfections. So based on that, the quality of buffing will be reviewed. Like that, for every activity, we should have a system of review of maintenance activities. And we also should have OEM recommendation on lifespan of machinery, lifespan of critical parts, and the lubrication schedule and maintenance schedule. For example, Lakshmi Machiners will be giving a schedule of cordway replacement. Cylinder wire should be replaced once in 800 tons. Rings should be replaced in a ring frame once in 5 years, like that. Likewise, the comber oil changes. Every 6 months it should be topped up. Every 2 years it should be replaced, like that. OEM recommends for the lubrication also. We should follow that. And we also should have skilled and competent maintenance group for taking up the second generation maintenance. And we also work with budgets for regular budget as well as replacement budget. So management plan for the expenditure for every month. So the second generation maintenance example is routine maintenance cleaning, machine cleaning, lubrication schedules, resetting of machines, grinding of cord wires, top roller cords buffing, spindle centering, CMRS, concentric movement of rings to spindles, and also replacement of critical parts. What are the examples for replacements? Replacement of cord wires, replacement of top combs in a comber after 2 years, replacement of rings after 5 years in a ring frame, replacement of front footer rollers in ring frames once in 6 years, replacement of inserts within 3 months to 18 months depending on the counts in compact ring frame. These are a few examples of replacements. What are the advantages of second generation maintenance? It is a well-planned systematic activity. Budgets and control facilitates financial planning for the top management. There is no surprises for the top management. OEM vendors are freed from surprise calls from the mills. Production schedules are met by us. Yarn quality is as planned and agreed for the approved maintenance program. Please note, yarn quality is as planned only, as planned. For the given maintenance program, for the given replacement program, we can assure this quality. So we are committing to the management as well as the customer. That is, the qualities also will be as planned. OEM vendors, what is the role of OEM vendors? The roles is limited to the maintenance instruction manual, where they give lubrication schedule, maintenance instructions, and the care to be taken for the electrical and electronic parts. Interaction between the cross-functional team in shop floor, production, quality, and maintenance is almost nil, because it is also a stereotyped activity only, and everyone lives in their own islands. In the second generation maintenance, people felt we want to improve the coordination between production, maintenance, and quality, shop floor coordination. So that is why these concepts are generated. One is total productive maintenance, another is FMEA, failure mode effect analysis. Third one is 5S, shop floor excellence. Fourth one is process and maintenance audit system. What is total productive maintenance system? TPM helps to improve machine design, machine performance, and also the systems in the spinning mills to improve utilization of machinery, mainly utilization of machinery, increase productivity, kilogram per hour or units per liter, and also it helps to create a safer environment, fail-safe gadgets, or in Japanese words, it's called a Pokayo system. It also helps to improve quality and performance of the machines. TPM also helps to reduce rejections and wasted materials in the process. It also aims at keeping the cost of quality lower. That is, manufacturing cost has to be improved, because quality is not free. Just to meet the customer requirement, just like that, we cannot take the comber oil or flat strips. We have to be very careful of the cost of quality also. And mainly TPM involves everyone in the total process. Main objectives of TPM, in simple words, we can say we are aiming at 0 defects, 0 breakdowns, 0 loss, 0 accidents, 0 complaint, whether it's internal or external. So TPM has 8 pillars. What are the 8 pillars? Autonomous maintenance, individual improvement, planned maintenance, education and training, quality maintenance, initial control, office TPM, safety, health and environment, C pillar. So there is some Japanese words for some of the pillars also. Autonomous maintenance, Jishu Hosen, JH pillar. Focused improvement, Kobetsu Kaizen, KK pillar. Planned maintenance, Keikaku Gozen, KH pillar. Quality maintenance, Quality Gozen, QH pillar. So let us see what is being done in autonomous maintenance. In the autonomous maintenance, we will be selecting a machine and then we will do a initial cleaning and inspection. So whenever we do cleaning, we always focus on inspection of the machine parts also. We will try to locate what are the origin of defects. During the inspection process, we also try to find out what are the origin of defects. And then we develop tentative standards for every parameters. After that, we follow the general inspection follow. Then we also try to make it autonomous maintenance so that the visibility of the parts is improved. Once it is all done, we standardize our procedure, operational procedures. Then it becomes the autonomous management. The operators will be ready to handle the entire maintenance operation. For example, some machine will be taken as a manager model machine and a manager model team will be formulated. So the manager model machine will be inspected. After that, we will follow the step 1, 2, 3, whatever we had discussed in the previous slide. So once it is completed, we will deploy to other machines. For example, if card 1 is selected for this as a model machine, after completing SOP, we will implement in all the 24 cards in the department like that. So every department is will be going ahead. So we will try to follow with the autonomous maintenance teams. The objective of this autonomous maintenance is make the operator as an expert of equipment and become manager of the equipment. He should have the competency in autonomous management of the machine. And we also try to eliminate breakdowns occurring due to accelerated deterioration, because we are not allowing the dust deposits or wear out parts due to absence of lubrication. And we also try to improve visual management in shop floor. And we are also trying to push them to learn to participate in Kaizen activities. What is Kaizen? Kaizen, you can break the letter into 2 words. Kai stands for small. Zen stands for improvements. Kaizen is a small improvements. You might have seen this Maruti Zen vehicle. What is Maruti Zen vehicle? Actually, Maruti is a small vehicle. Then Maruti Zen is a small improvement over Maruti 800. So that is why the vehicle is called as a Zen. It's a Japanese vehicle. The Zen is called as a small improvement over Maruti 800. Now coming to individual improvement, KK pillar. Here, the pillar focus on utilization improvement. This utilization improvement by reduction of losses and human related downtime. Main focus is to reduce the manufacturing cost because of utilization loss. What are the factors affecting utilization loss? Losses preventing efficiency of material and energy, losses preventing the efficiency of manpower itself, losses directly affecting the machine utilization itself. Here we coin a term called OEE, overall equipment efficiency. This overall equipment efficiency is a simple multiplication factor of utilization, production efficiency, and also the rejection, 100 minus eject percentage. For example, your utilization is 97%, your production efficiency is 99, you have a 10% rejection. Finally, it will translate into 86.5 overall equipment efficiency. So this is one example. What is the expected OEE for a spinning mill? 99% utilization, 100% production efficiency, 100% quality efficiency. That means our OEE of a good spinning mill, where the TPM is in control, should be 99. Focused attempts should be made to eliminate or reduce all kinds of losses leading to utilization loss of every individual machines in a spinning mill through this pillar. The third pillar is planned maintenance. This planned maintenance is improve the reliability of this equipment, whether we can rely on this machine as a good machine, whether it will continue to run, whether can I commit to the customer by relying on this machine. That is the aim of this planned maintenance. Here there are 2 important terms, MTBF and MTTR. MTBF is mean time between failure, MTTR is mean time to repair. How we are achieving that? We are trying to achieve 0 equipment failures through establishing the basic condition of the machines. So basic condition, what do you mean by basic condition? When the machines are sold, it comes with a certain condition. The same condition has to maintain throughout its lifetime. That is called basic condition. So we should eliminate causes or factors for accelerated deterioration. Then we have to abolish environments causing accelerated deterioration. For example, in a ring frame, reader ring frame inverter, there is a cooling arrangement for the ring frame main drive inverter. If the inverter cooling arrangement is not working, the inverter fails within 24 hours. So you should maintain such kind of environments, abolish environments causing accelerated deterioration. And you should correct design weakness and lengthen the life of any parts. For example, when the Susan gives a retrofitting for G5 for one ring frame in spinning mills, in many spinning mills, the front roller shaft immediately breaks down after the retrofitting. So they studied that, then they found out because of the extra load on this mango tube on this top roller system, so the front roller is exerted with a higher pressure. So immediately the design weakness is corrected by the sturdy front roller end. So like that, we have to correct the design weakness and lengthen the life of the parts. And more importantly, we have to improve skills and eliminate of all the maintenance crew so that we can eliminate unexpected failures. The mean time MTBR, mean time between repair. So we should study the time taken between the repairs in a particular machine. For example, in a ring frame variator failure in a particular ring frame. So any breakdown, it should be prolonged. Actually, there should be a time gap between the breakdown. There should not be any breakdown at all. If at all there is a breakdown, it should not recur so fast. So that should be studied between the frames. For example, ring frame 1, if the mean time between repair is 6 months, so that should be maintained in other frames also. If the second ring frame is breakdown within 3 months, we should study and improve the condition there. So finally, the time taken for mean time between repairs should be extended so that the utilization loss is minimized. Likewise, mean time to repair. This is one of the most important factors which I want to highlight also. You know, one of the spinning mill where TPM is implemented, there was a unilab breakdown in the day shift. That unilab was rectified immediately within half an hour time. The same kind of breakdown repeated in the third shift in the same mill after 1 week time. For the same repair, the mill took 3.5 hours. So what do you mean? What do you mean by this 3.5 hours? Half an hour and 3.5 hours. There is a 7 times. It's a stoppage of the machine. So this has been studied by the mill in the TPM procedure. So what they found out is it's a laughing matter actually. The time taken for the fitter to repair is only half an hour, but time taken for the fitter to come to the spot is taken 3 hours. That means it's a communication failure between the gate and the fitter, as well as the production supervisor in the time hours, like that, so many issues. So the reasons can be so many. So you should understand the MTTR and MTBR are very good factors to improve the reliability of your equipments. Objectives of this education and training pillar, and that's normally called as ENT pillar. Here we have to eliminate breakdowns due to poor skill or competence of the staff or maintenance crew, to eliminate operator mistakes leading to customer complaints, defects and accidents. Actually, in TPM based mills, customer complaint fabrics or cones will be taken to the work spot and will be discussed with the operators themselves, because operators are always with the machine. They know how the defects are being produced. So we should involve them, we should educate them, we should get trained from them also. And we should develop multi-skill in operatives. And we should improve the skills of the maintenance personnel also. Finally, we should try to achieve zero non-conformance due to lack of skill. That is the aim of the education and training pillar. The workers must be able to detect and eliminate abnormality by seeing the conditions itself. And they should be able to do Kaizen by making some small suggestions. They should give some suggestions for reducing the cop rejection, reducing the package defects like that. And we should develop multi-skill. For example, today, all the mills are going for individual spindle monitoring systems, and also they are using e-bike. So the operators must be able to read the content in a dashboard, they read the dashboard content in the e-bike also. So it is a multi-skill operation today. They should be educated to the computer display and act on that. So develop skills of maintenance. Some of the operations they should be trained to do that also. Finally, they should be able to teach the next worker, nearby worker also. Like that, we should develop them. Next comes the quality maintenance pillar. That's the fifth pillar. Here, we are trying to do 100%, simulate 100% inspection. Almost all of you will accept with me that 100% of the inspection of the product is not at all possible in a spinning mill, because every day some of the mills will be running with the 25 tons of production every day. So it's not at all possible to spend time on that. So, however, we should try to simulate conditions of a 100% inspection, like building the quality into the products in the in-process. That is, we have to eliminate in-process defects. For example, if the customer is very serious about plus 140% imperfections, then we should be very cautious on the Comber, NEPS, delivered in the delivered sliver. Like that, you should set standard for the Comber NEPS itself for the customer requirements. And we should try to eliminate customer complaints of all sorts, whether it's internal or external. And we should also aim at cost of quality should be reduced through elimination of defects and rework. And also, we should demand JIDOKA from OEM vendors. What is JIDOKA? JIDOKA is nothing but automatic detection of errors and defects in the process. For example, seat belt alert in a car. If you don't wear a seat belt, it leads to accidents. It's not going to lead to accidents, but when the accident happens, you will be affected more. So when the car is started, it will give you an alarm signal, seatbelt alert in a car. So this is called a JIDOKA. Likewise, alerts when handbrakes are not released while we start the machine. Likewise, slip spindles in a individual spindle monitoring system, because slip spindles lead to quality defect. Alarm generation modern clearance when the clearer cuts are more or copper rejections are more. Alerts generated by individual spindle monitoring systems on broke spindles in a ring frame. These are all coming as JIDOKA. You should ask for JIDOKA from the OEM vendors. How will we concentrate on a ZDQC, zero defect quality control? You should concentrate on origin of quality defect. When you know the origin of quality defect, then you will establish material condition yielding zero defects. How will you establish? For example, you are working on contaminations in a fabric. So you will see that cotton is purchased with a lesser contamination. So establish equipment conditions yielding zero defects. For example, you are having a contamination clearer. Then you are expecting the number of ejections per hour. You are setting the machines for a based on the contamination of the cotton. So 2500 ejections per hour you will be maintaining. Then establish methods condition yielding zero defects. What are the methods? So how do you clear the contamination? What are the methods being followed by the worker? Then establish operating conditions yielding zero defects. What is the operating condition? Maintaining RH level in a autoconus section. If you don't keep an 65% RH, your clearer is not going to function. Then the operating conditions in a autoconus department has to maintain like that. So based on this, we have to achieve the zero defect quality. Then comes our initial control activities. The initial control activities சொல்லும்போது தமிழ்ல ஒரு பழமொழி உண்டு. முதல் கோணல் முற்றும் கோணல் அப்படினு சொல்லுவாங்க. That is, do it first time right. Whenever you do something new, try to do it first time right. So whenever you are working on a new product or sampling procedures, you should try to reduce product development time, that is sampling time, because customer is not ready to wait for your sampling development time. Likewise, whenever a new machines are started in a new project or even in a modernization program, new machines should be started within the short time, and we should reach 99% OEE within 1 month of commissioning, because it has some economical impact on the mill. This sixth pillar will concentrate on this initial control activities. Seventh is she pillar, safety, hygiene and environment. We should attain and maintain zero accident level by proper safety committees, canteen committees and everything. Create a healthy and clean working area around the mills by proper planning, and create and maintain zero pollution level by proper checking of the air pollution level and water pollution level inside the factory. Then comes the administration TPM. In the administration TPM is being taken lightly in most of the mills, but administration TPM is more important because HR also is coming at the administration TPM, where 5 years is a major part, and also the attendance and this time taken to pass the bills, time taken to receive a guest, everything, communication improvement. So if the administration TPM is not proper, the image at the customer level will be spoiled. Benefits of TPM. The total productive maintenance helps to maximize utilization efficiency, improve machine productivity, improve machine design, reduce rejects, and finally, it helps to involve everyone from the operatives to the GM level. Next technology concept is FMEA, failure mode effect analysis. FMEA is first coined by aerospace, which is used in 1960 itself. Widely used by automobile industry globally, first promoted by Ford food global level. In 1990, government industry is attracted by FMEA. It started introducing that. After that, spinning mills slowly followed the government industry from 1990s on FMEA. What is FMEA? It is a systemized group of activities intended to identify the potential failures of product or the process, inherent process. And then we will have the responsible person to act or to eliminate or reduce the failures or the impact of failures by a team of responsible person. Finally, to document all these activities as a standard operating procedures. For example, we will take a contamination in finished fabric. Customer has complained, their expectation is 0.5 contamination per 20 kg of fabric. So what are the things to be done? What are the data to be collected? Contamination cotton, contamination picking efficiency by the operators, ejections per hour in a contamination cleaner in blow room, clearing efficiency in that machine, then autoconus settings per clearing, autoconus clearing efficiency, then contamination per kg in a gray knitted fabric, and contamination per kg in a bleached fabrics, and contamination per kg in a dyed fabric. All this form the data for the FMEA. Then who are all the responsible persons for this? Since cotton contamination is to be noted, procurement in charge is responsible. Then QA in charge is responsible for contamination data in the department. The training in charge is responsible for the methods in the contamination picking area. The maintenance in charge for the contamination clearer setting and the autoconus setting. So all these persons will be called and discussing on this subject, and they will try to form the strategy to improve contamination clearing efficiency, finally to reduce contamination in the final fabric. So they will implement action, they will review the action taken, they will go on review and the action taken by assessing the final finished fabric. Likewise, FMEA for everything can be, for the process or design can be done in a spinning mill. Best example of design FMEA by OEM vendors with the spinning mills is Contra flat tops by Lakshmi Cord Clothing, and also the geometric conversion that is normally called the short stitch conversion for compact spinning by LMW. So you know the Contra tops. In the normal flat tops, regular flat tops, fiber moves in the straight line. Like that, the fiber moves in the straight line. Whereas in the Contra tops, in the Contra flat tops, fiber is allowed to move in a zigzag way by arranging the flats in a zigzag way. That is, right helix angle and the left helix angle will be alternatively placed in the flat tops, so that it helps. What are the advantages? Enhanced fiber separation in between cylinder and flat tops, significant reduction in sliverness per gram. More importantly, you are saving minimum 0.5% raw material, maximum of 1%. So the flat tops will be paid back within a 3 months period from your end. This is an advantage of design FMEA by LCC. So in the FMEA, we also go by RPN, risk priority number, which is calculated from occurrence of the defect, severity of the defect, detection ability of the defect. Based on these 3 factors, we are trying to create RPN also. So what are the advantages? We are developing cross-functional team. We are able to eliminate the potential causes. We are able to develop standard operating procedures. We are able to develop problem response plans. We are able to develop good customer vendor rapport. So 5 years, I don't like to dwell more time on this 5 years because all of you are aware, because SAIRI is a sorting, SAITEN is for orderly arrangement, SAISO for cleanliness with inspection, SAIKETSU for standardization, SITSUKE for assigning the responsibility for sustainability, which almost all the mills are aware about 5 years. Then comes the machinery maintenance audit system, 4th one. This is internal or external audit system on mills. Maintenance management system helps to unearth the deviation schedules within the mills against recommendation by OEM. Wear and tear of parts can be identified. Based on the wear and tear of parts, adequacy of maintenance schedule and the lubrication schedule will be identified. Yarn quality level and consistency will be studied, so that impact from improper maintenance will be studied. Quality of tools and cages will be studied by the auditing team, and then We will also try to use advanced techniques of machine auditing also, like thermography and air leakage detector, etc. Going to the third generation maintenance. Third generation maintenance is 1975 to 2000. This is nothing but a predictive maintenance. So how do you do that? This is a condition-based maintenance. Only based on the condition of maintenance operation will be done. So mostly it is we are able to help by computer during this period. We also work towards multi-skilling of working force, and teamwork is a result of this. And we go by a proactive approach in this maintenance systems. Here, OEM intervention, apart from instruction manual, offline training and on their maintenance with the most competent engineers and technocrats at whether it's LMW or Treasurer or Reader, it's happening in the factory itself, so that people are aware of the machines and its condition, how to attack the condition-based maintenance. Use the information on equipment's condition to repair or replace a component. Parts and wear items are replaced only when necessary based on quality deterioration, temperature increase, noise or vibration increase, or air or oil leakages. These are 4 factors. What are the advantages? Maintenance cost can be reduced because it is not stereotyped. Each plant can modify their maintenance practices based on the environmental condition. For example, it's a seashore mill, rings will be spoiled more often, like that. Machine learning is a boon to shop floor technicians. Shop floor technicians are being trained by the OEM vendors at the factory level. For example, what are the PDM tools? When you say predictive maintenance tool, what are the tools? Advanced QA equipments like Office Pro, TensoJet, UT5 and 6, advanced clearance with Cone Expert system, ring data, load manager and energy sensor, ultrasonic leakage detector, thermal images, vibration sensor, digital stethoscope. How do we do that? Office instrument is used to predict the life of cord wires. Today, cord wires are not replaced as a stereotype, not based on 800 tons. It is based on NEP level and also the NEP removal efficiency in the cord. Mills have even double the life of cord cylinder wires, even up to 2000 tons in some of the mills, we can say. Advanced clearance help to track the CVF imperfections from ring frame, and the cord's buffing cycle can be extended based on that. TensoJet is used to estimate the weak places variation between compact ring frames on the same count and take decisions on traveler replacement schedule, mango tip cleaning schedule, change of inserts, change of perforated apron itself. Ring data clearly identifies the rogue spindles, less twist spindles, so that tape schedule can be modified. Spindle centering activity schedule is extended from once in 6 months to once in 2 years in many mills after ring data implementation. Load manager, how is being used? These are used to estimate the energy consumption in ring frames, and suitable action for lubrication or parts replacements are being done. For example, 10-roller bearing replacement. Air leakage detectors are used to test leakages in autocones, and multi-jet valves or splicer gaskets are replaced before it starts affecting the product quality. Thermal images, they are used to measure the hot spots in the motors or in the control panels. Actions are taken before it leads to any unsafe fire accidents. It is a vital PDM tool for predicting the health of motors, transformers, stabilizers, ACB, VCB, switchboards. Best inevitable tool, PDM tool in the mills. Now, we are also having, there is an extension of third generation maintenance that's called smart predictive maintenance, SPDM. Beyond 2010, IoT enabled devices helped a lot to work for real-time measurement of conditions of machinery. In the previous slide, we were discussing about measuring offline. For example, thermal images help measure the temperature once in a period of 3 months or once in a period of month, like that. Here, on-time, real-time measurement is possible. That's what SPDM tools will be doing. From the real-time data, collective information drawn on performance level of KPIs like air leakage, hotspots like temperature of a motor, temperature of AWS motor, like that. Energy consumed, everything is being recorded throughout the 24 hours. Based on the real-time data, we get the health of the asset. Performance metrics are established and alerts are inbuilt to stop the machines if the limits are exceeded. range in performance parameters also can be inbuilt. Now, before going further, let us dwell something upon the industrial revolutions. Industrial Revolution 1. First industrial revolution started in 1784, which brought mechanization, steam engines, power from water and steam, new manufacturing systems in iron, textile, mining, metallurgy, and machine tool. This is 1784. The second revolution starts in 1870. In the second industrial revolution, there is a mass production, technological electrification, globalization of trade, and engines and turbines are used for the industrial purpose. So, two mills in India directly generated power using hydro turbines in the 1900s itself. For example, it's the Majra and Gogol spinning mills. Power is drawn from the water turbine. The third industrial revolution is 1969. It is enriched with computer, internet, digital manufacturing, PLC, robotics, automation, digital networks, and digital machines. Best examples in spinning mills are industrial revolution. Third is blendomet, quantifeed, auto levelers and auto consciences in draw frames, auto doffers in ring frame and auto corners, auto splices, advanced clearers, link corners, auto pieces in open and spinning. It's an example of industry 3. The last one is industry 4, where we are looking at it. Industry 4, fourth industrial revolution. The year of start is 2011. Here, there is a merger of information technology and operation technology. We call it as a convergence of IT and OT. Simply called as IoT also. And we are looking at autonomous machine. That is, we don't like to have human intervention. We are focusing on less human intervention. And we are trying to use advanced robotics in all operations. And we use cloud data, Internet of Things, smart factory program, and the platform is always artificial intelligence in Industry 4. What are the goals of Industry 4? Mainly automation, less human intervention because the human power is costly today, and process improvement should be made automatic, productivity and production optimization. If the machine is capable of running at 25,000 and delivering at 25 kg per day, we should get the maximum output from the particular machine. And innovation and smooth transition to new business. Industry 4 stands for smart industry and smart manufacturing. Industry 4 in spinning mills. What are they? Advanced clearers with smart clearing curve. See, after the invention of the smart clearing curve in advanced clearers, do you see there is a role of any QA manager or quality experts in QA department? Today, even an operative can go and set the machine based on the fabric expected requirements translated into clearing curve. That's very simple process today. And then bobbin transport system. The production planning itself is well organized with the help of bobbin transport system and the cone transport system. Moratex visual manager system is a boon for Industry 4 in spinning mills today. All individual spindle monitoring systems coming under Industry 4. Smart series machine from LMW, smart series machine. For example, LRJ S9XL. LRJ 9SXL from ring frame. LMW has sensor for energy consumption and air consumption to capture real-time data. They are supplying along with the machine itself. And spindle ID, that is spindle identification system auto corners, identifies the rogue spindles in the ring frames so that we can correct the same immediately. Now we have individual spindle monitoring system which helps spinners to identify the rogue spindles. Real-time data helps immediate actions, and machines are not at all stopped unnecessarily for spindle centering or top arm corrections or mango tube correction, which all help to improve the utilization of ring frame to 99.2% today. In some of the mills where ISM are installed, mills are getting 99.2% utilization. Please note that. When you say this OEE as 99, today you can set the standards for 99.2. Help monitor in spin connect of LMW. Customized solutions from LMW for SPDM tools for critical zones like ring frame motor, Comber headstock, it's also available. Energy, temperature, vibration levels can be measured, and the health of the machine is monitored 24 hours, which helps for predictive maintenance. Please note, you can set the standards also. performance metrics for all this temperature and the vibration level. Then comes from Worcester, that's a total testing center, which identifies the history of probe spindles in conjunction with Worcester Sentinel and UQ for clearance. This helps to improve the ring frame performance from clearer function itself. And then Pinterest Smart Dragon, which connects critical zones for real-time data and raise alerts and provide reports. We can make it tailor-made for all spinning machines and utility equipments, including AWS or humidity plants. What are the recommended SPDM tools? Thermal sensors for AWS, that is automatic waste evacuation centrifugal motors, ring frame main motors, VCB, ACB, and compressors. Ultrasonic vibration sensor for ring frame motors, Comber headstock, humidity plant motors, AWS centrifugal fan motors. Ultrasonic air leakage reduction sensors for autoconers, lap formers, autodoffers, and link corners. These are the SPDM tools we can think of so that we can get a real-time data. Further to that, humidity sensors after eliminators in humidity plants, energy sensors in critical zones like ring frames, autoconers, humidity plants, compressors, AWS centrifugal fan motors. Most of the mills don't have even power consumption standards today. So based on your spin plan, based on your allocation of machinery, based on your allocated utilization status, mill should know what is the power consumption standard. From the level of power consumption standard, are you achieving the standards? So energy sensor will help you to tap the data on that. Benefits of the SPDM tool: we get real-time data on hotspots, air leakage, energy consumption, vibration level, reduced air saturation efficiency from the humidity plants. With the use of IoT-enabled devices as above, maintenance management becomes smart with a lot of focused activity. Now, coming to the fourth generation maintenance. This is quite interesting program. SPMF. We call it as a SPMF, Smart Prescriptive Maintenance Framework. Why we call it as a framework, we will come to later. This is coming, this is, we are able to do it from 2017 beyond. It is identical to SPDM. Over and above SPDM, we are trying to automate the maintenance practices. It provides recommendation to replace or repair or replace the components. Purpose is to improve machine learning. Collects data of failures of the machines and its causes from the cloud data and pools actions to correct such failures, and then it transforms into recommendations to the users globally. Platform used is artificial intelligence. Prescriptive maintenance is the growing technology at a faster pace by utilizing artificial intelligence, IoT, cloud data, analytics, and machine learning. The information gathered to the real-time data from the sensor will be utilized to prescribe corrective actions and pass instructions. SPMF can be alternatively called as an automated maintenance process. What are the inputs into the SPMF? Most critical KPIs of the system. If you take examples of autoconers, what are the KPIs of this autoconers? Misplacing percentage, drums with more clear records, like that. So knowledge bank, history of failures and the corrective actions taken by us. MTBF, mean time between failures. What is the time taken for the mean time between failures? What are the remaining useful life of a critical? For example, what are the useful life for a splice a gasket, like that. Best tool for this SPMF today is Visual Manager Systems as supplied by the Muratech. It collects KPI like a failure of operand sensor, MUP percentage, MSL misplacing percentage, number of missed auto doffing, NADM, MLC clearer malfunction, etc. There are so many parameters there, and it also benchmark autoconer performance based on the cloud data available elsewhere from the user data. Then it also gives a recommendation on the part to be replaced. In the VMS, they are also storing the key performance indicators. Standard performance levels for each performance characteristics is stored in the based on the cloud data. In case of deviation, it pins down the reasons for the failure and also prescribes the actions to be taken, whether to replace or repair. It also suggests the parts to be changed with a descriptive diagram, which is more important. Visual Manager in Auto Corner clearly identifies the rogue drums where critical performance metric deviations are more. Maintenance crew need not stop the machine unnecessarily for checking the splices or drum setting. Elimination of routine machine cleaning or routine maintenance is stopped. What is it available in the VMS? Key performance metrics, content of the problem, checkpoint, which point to be checked, what are the consumable parts, how to replace the parts. It is training us to do the job. Periodical health report is also being given. It's a display of this program. I think the slide is visible to all of you. Content of the problem is explained as tension break increase due to abnormal tension force. This is the content of the problem. What is the checkpoint? Check the movement of tension finger by hand. This is the checkpoint. Check consumer parts. What are the check parts, consuming parts? Bearing. If bearing is damaged, it should be replaced. Then how to replace? Replace the bearing simply. Please be careful about position of bearing and order of the other parts. Like that. This is given in a descriptive diagram. The next slide shows the diagram also. The parts where the parts are there. What are the parts to be bought by you? What are the prerequisites for SPMF? OEM and as data collection and KPIs for which we have to provide the data. The user mills have to provide the data. Training of the users by OEM. Visual Manager cannot be simply used by any mills. It has to be trained by the OEM vendor. Review of performance on a daily, weekly, monthly basis on prescriptions and follow-up actions. VMS delivers daily report, weekly report, monthly report. This should be studied by the concerned maintenance crew, concerned GM, concerned MD, so that improvement can be attained for the based on the VMF. This framework covers performance of real-time data, benchmark performance standards based on cloud data, machine learning, fault history and tribal knowledge, IoT enablers, FMEA, that's a failure mode effect analysis, failure mode and effect criticality analysis. Then since this maintenance works on this framework, we call it as a smart prescriptive maintenance framework because it's a performance real-time data, benchmark, machine learning principle, IoT enablers, FMEA system. So that is why we call it as a SPMF, Smart Prescriptive Maintenance Framework. What are the suggested? Now, based on this program, I would like to suggest some goals for the smart spinners. So smart spinners should work towards maximum automation in their new projects or in the existing mills wherever possible. There should be less human intervention. We should work towards systems where we can build the quality into the product through ZEQC and FMEA. And we should be able to predict finally on quality with the systems like TTC. And we should be able to predict end-use performance with the help of UQ4 or TensorJet. And we should also try to go in for new machines like where automated waste controls are established, like Tesla carts are being done, Lakshmi carts are being supplied with automated waste controls. And we should go with modern clearers with the smart clearing curve. Real-time data, we should try to go in for production monitoring system, individual sprinting monitoring system, VMS, mill masters, Spin Connect, Smart Dragon. And finally, we should go in for SPDM and SPMF so that automated maintenance system. Smart spinners can adapt what is best suited for the present condition of the mills and move ahead towards SPMF, SPDM for all critical assets of their organization. So let's be a smart spinner aiming at your goals. Thank you very much. With this, I am closing the session. Thank you, all of you. Kandiraj.
Thank you. Thank you, sir.
Thank you very much, sir. Mr. Gandhi.
Welcome.
Analysis on the maintenance, and I hope it will be very much useful to all the participants. And I think they would have noted down. And I expect many more questions on this. I think any participants having clarification can raise hands or post their positions in the question box or send the chat box also. So, yes, of now, I think there is no question on the chat box also. Chandran and Rajashekaran have given the presentation. I think Satyanarayan sir, I think if you have any clarifications, I think we also can make get it clarified from.
They can clarify with my mail ID also, sir. If they can post it to TA.
One question has come, sir.
Okay.
The name is not given.
Okay.
Is there any automation for drafting zone cleaning in ring?
So far, it is not available. Somebody has to work on that. But OSTC systems are made very good. Draft zone cleaning is made. But the manual cleaning cannot be taken away from that. Manual cleaning is a must for the draft zone cleaning. That should be continued for the present level.
So no other questions are being asked. So shall we go ahead with the summing up of the program? Meanwhile, if anybody asks, again, we can answer, I think.
Useful maintenance presentation, sir. Thanks. Saravanan Ganesh.
Yeah, all are sending a good presentation. Thanks, like that messages are coming. No specific questions.
That's also appreciated. I think we can go ahead with the
Summing up of this program. So, Vinarana, shall we go like that? Yes.
Okay. Then now I request our joint secretary, Mr. A. Sivaramakrishnan, to sum up the presentation of Mr. Gandhi and give a vote of thanks. Deliver the vote. Thanks.
Good evening, and dear participants. Now we are in the last part of the program today. Today our Gandhi Madinadan made an excellent presentation with highly invaluable information from the evolution of creation. More than 4 decades of rich experience and good expertise in production, quality, maintenance, and stock management areas reflected in the presentation of 100 slides. See, 100 slides in 66 minutes. I noted the time at which he started and also time at which he finished. So 66 minutes, 100 slides. It is something like in a cricket match, how a batsman is scoring a century in 66 minutes or 30 minutes or something. Next, he has clearly shown the way in which the first generation maintenance and second generation and third generation and fourth generation maintenance activities have been carried out right from 1940 to till date. He showed very clearly the impact of absence of maintenance and the substandard maintenance, how it is affecting the mill performance, production and quality performance, along with the needs and types of maintenance. In the first 10 slides, he explained the first generation and second generation maintenance features, advantages, and limitations. 4 slides in first generation and 8 slides for second generation. Then coming to TPM, second generation, 24 slides. See, it is, I am not able to explain, I am not getting suitable words. The objectives, stages, pillars, tools, and advantages are explained with examples. 50, LB DAC. zero loss, zero breakdown, zero defect, zero accident, zero complaint. How to achieve? What is needed to achieve these 5 important factors? Education and training and quality maintenance, and all these things he has explained in a fantastic manner, easy to understand. Then he also explained 4 stages and 8 pillars and the TPM tools, overall equipment efficiency. This is more interesting, highly informative, and more useful. And also he has explained safety and hygiene factors and environment, and also failure mode effect analysis, a systematic application of engineering knowledge to eliminate the failures, potential failures by means of optimizing design, process, product, and services. He has also given lots of good examples, contamination in yarn and fabric. He has also mentioned about machinery audit and fiber services, internal audit and external audit. About 56 slides he has shown the very important thing, the way in which it is presented today. It is something like a deep breeze from southern direction, what we call central carpet. Seeing the heat and the gentle blow of air from southern direction, we are getting in the evening, months of June, July, August, September, right from May 15th. Same way, his flow of presentation is very nice, very much appreciable. Then coming to third generation maintenance, he has explained very well about the predictive maintenance and also SPDM tools and a lot of information about the production machines and online monitoring system, measurements, automation, industrial scenario at 4 levels, level 1, level 2, level 3, level 4. Then afterwards, he has given 4th generation maintenance, SPMF. In the system, he has clearly explained how information technology is integrated with operation technology and also less human intervention. So SPMF, he explained with 17 slides how an automated maintenance practice provides corrective actions and fast instruction with IT. So artificial intelligence, IoT, cloud data, and individual single monitoring system, health monitoring, energy, temperature, vibration, all these things he has explained without any missing. He has also clearly mentioned the advantages of SPMF. And finally, I can tell 4 important. He took us from 1940 to till date. First generation, only routine maintenance. The second generation maintenance, reduction and the prediction of breakdown to improve the quality and performance of machines area by TPM, FMEA, machinery audit, and fiber. Third generation maintenance by PDM and SPDM. And 4th generation maintenance, fully automated maintenance practices which describe corrective action and fast instruction. All these above practices are adopted. See, this is the place where we have to concentrate. See, what is the advantage? Higher GPS, 150 to 125 grams per. In the last 2 mills, I have visited 1 mill. 2 mills I have visited. Their GPS is 150 to 125 grams. The utilization is 98%. Idle spindle mill, I visited 2 times, 3 times in a day. I was not able to find out not even a single idle spindle. Then the pneumatic waste is less than 0.7%. What is UKG? They are getting only 4.1 to 4.3. The other mills, where this is not properly adopted, they are getting 4.7, 4.8. So at 120 grams, 125 grams, 128 grams, it is not possible for anybody else to get less than 4.5 or 6 without adopting this systematic maintenance procedure. The last important point, less labor turnover. We are facing a lot of problems in the mill. See, laborers are migrating, migrated laborers are not staying with us. When I asked that mill, they told me, sir, we are not facing any problem. We are not facing any problem. 95% local labor, only 5% is the migrant labor for loading and unloading purpose. See, this is the scenario when all the maintenance practices are systematically adopted. So increase in production percentage, highest utilization, then the lowest energy consumption, the lowest idle spindle and lower pneumophyll waste. So because of the better atmosphere and also adoption of 5 years practices, the mill looks like a star hotel. The mill of 2008 technology with available machines. Even today, after 10, 11 years old, the mill seems to be star hotel. Right from the entrance, till every corner of the machine, so much cleanliness is maintained by 5 years practices. 5 years practices is not going to cost too much. It is only few thousand, less than a lakh, or even 1 or 2 lakh rupees. Even that is, many mills are not ready to. What said, every mill has to implement, try to achieve very good production per mill, better utilization, very good working atmosphere, and less labor turnover, less pneumophyll waste. Now, finally, I can tell only one thing. This is a super specialty presentation, not an ordinary presentation. It is a super specialty presentation. I have no other word to describe. All the points are well penetrated and recorded in our brain and heart. Like our attitude by Avaya. See, at the age of 5, 6, all of us are studying attitude, Avaya, Arundhya, Varumbi, Arvadikam, about 65 years ago. Still it is linking in our mind. So today's presentation is unforgettable experience for everybody. And finally, coming to vote of thanks, we are very much thankful to all our participants of this program for their valuable presence and time on behalf of Textile Association South India Unit, and also from all participants, our grateful thanks to our Gandhi Madinathan for his invaluable and excellent presentation. This is more appropriate and the finest example for Tirukural. Selvathul Yellam Sivichelvam Achelvam. Selvathul Yellam Kalai. Selvathul Yellam Sivichelvam Achelvam. Selvathul Yellam Kalai. For his presentation is the greatest of all, which I have not seen this kind of presentation in the last 49 years. Frankly telling, the 49 years, no one has presented hundreds of slides within 66 minutes with smooth flow of presentation. It has penetrated in our mind and heart. It is deposited. It is something like our attitude by Avaya. So with a few words, I will conclude my presentation for the summing up and the vote of thanks. So best wishes for Gandhi Madinathan.
Thank you, sir. Thank you very much. Thank you.
Thank you very much.
Thank you very much, sir.
Welcome.
I think meeting ended well, and with a great appreciation and note on the speaker. And we are also very much thankful to all the participants having approved our annual report. And we continue to serve for the coming years also. And we need your support, full support, and to retain all the participants to become the member in our association. So that will strengthen our over attending, and we are conducting one program. So it is very useful to all the textile industries, and also already we will get the same support in future also, and we will continue to serve the textile industry from South India. Thank you very much.
Welcome.